In 2013, the Spanish Navy was preparing to unveil a masterpiece. It was meant to be the crown jewel of their armed forces, a stealthy, lethal, state-of-the-art apex predator of the deep. It was called the S-80+ class submarine. The budget was nearly $3 billion. It was supposed to project Spanish naval dominance across the globe. There was just one catastrophic, mind-boggling problem. Weeks before the submarine was supposed to enter the final phases of testing, a routine audit uncovered a terrifying secret hiding inside the engineering blueprints. The submarine was 70 tons too heavy. In the brutal world of oceanic physics, 70 tons is the difference between a submarine and an anchor. If the Spanish Navy put their $3 billion pride and joy into the water, it would dive perfectly, but it would never, ever come back up. It would sink straight to the bottom of the ocean floor, permanently burying itself in the sand. How does a modern European nation spend billions of dollars, employ the greatest engineers in the country, and accidentally build a machine that forgot how to swim? Welcome to systemic failure. Today, we investigate the most expensive mathematical error in military history. To understand the sheer scale of this embarrassment, you have to understand the hubris that built it. For decades, Spain relied on foreign designs for their submarines, mostly partnering with the French naval defense company DCNS. They built the Scorpionet-class submarines together, a highly successful, widely exported vessel. But Spain wanted more. They didn't want to be the junior partner anymore. They wanted total independence. They wanted a purely Spanish submarine, built by their state-owned shipbuilding company, Navantia. The government envisioned a vessel equipped with cutting-edge, independent propulsion. This technology would allow the submarine to stay submerged for weeks without needing to surface for oxygen, making it practically invisible to enemy radar. It was an engineering flex, a multi-billion-dollar statement to the world that Spain was a top-tier military manufacturer. Navantia was handed the contract. The pressure was immense. Politicians were making promises. The media was hipping the project, and the timeline was aggressive. But behind the closed doors of the drafting rooms, the ambition was severely outpacing the reality. Spain had never designed a submarine of this complexity completely from scratch, and in the rush to prove their independence, they failed to set up the most basic, fundamental system of checks and balances. Submarines are a masterclass in the delicate balance of buoyancy. Every single wire, every drop of paint, and every screw must be meticulously accounted for. If the weight distribution is off by even a fraction of a percent, the vessel's center of gravity shifts, and the entire multi-million-dollar machine becomes a death trap. Somewhere inside the bureaucratic labyrinth of the Navantia shipyard, during the early design phase, a single engineer made a calculation, and in that calculation, a decimal point was placed in the wrong spot. Or, according to some insiders, a critical weight calculation was locked in pounds instead of kilograms. In a functioning system, an error like this is caught within hours. A senior engineer reviews the math, spots the stray decimal point, circles it in red ink, and the problem is fixed. But this was a systemic failure. The project was divided into heavily siloed departments. The engine team wasn't talking to the weapons team. The weapons team wasn't talking to the hull team. Nobody was strictly managing the master weight ledger. As the years ticked by, new systems, thicker cables, and heavier components were quietly added to the S-80's design. The misplaced decimal point had mutated. The error was baked into the foundation of the blueprints. By the time someone finally did the math to check the total displacement in 2013, the project was already being physically constructed, and the reality set in. The submarine was 70 to 100 tons overweight. It was a cataclysmic failure of oversight. Panic consumed the Spanish Defense Ministry. They had poured hundreds of millions into a steel tube that couldn't float. Humiliated, Spain had to swallow their pride and do the exact thing this project was designed to prevent. They had to beg for foreign help. They called in the Americans, specifically Electric Boat, a division of General Dynamics, the company that builds nuclear submarines for the US Navy. Spain paid the American firm $14 million just to review the broken math and provide a solution. The American engineers looked at the 70-ton problem and delivered the only physically possible answer. You have to make the submarine longer. To offset the massive extra weight, they had to increase the volume of the hull to generate more buoyancy. The Spanish shipyard had to physically slice the submarine design and splice in an extra 10 meters or 33 feet of steel. It worked. The math finally balanced. The S-80 Plus could float. The crisis was averted until they realized what they had just done. The newly lengthened submarine was now 81 meters long, and the Spanish Navy's submarine base located in Cartagena. The docks were only designed to hold submarines up to 78 meters long. You cannot make this up. Spain fixed their sinking submarine by turning it into a submarine that literally could not fit into its own parking spot. The entire naval base had to be restructured. The government had to spend an estimated $18 to $20 million to physically dredge the port, demolish concrete, and expand the docks just so their mathematical mistake had a place to sleep. What started in 2004 as a brilliant $2 billion project ballooned into a nightmare that took almost 2 decades to complete. By the time the first S-80 Plus submarine finally passed its dive tests and was delivered to the Navy, the cost of the 4 submarine program had skyrocketed to nearly $4 billion, almost double the original budget. The S-80 Plus is now a functional, highly capable warship, but its legacy isn't its stealth or its weapons. Its legacy is a monument to bureaucratic arrogance. It is a permanent reminder of what happens when communication breaks down, when politics rushes engineering, and when nobody bothers to double-check the math. We investigate broken systems and massive engineering blunders just like this every single week. If you want to understand how the modern world is actually built, and how easily it all falls apart, hit that subscribe button today. This is Systemic Failure. I'll see you in the next one.